Is the seventh lesson of iBuddy Science, and it will be about ions and isotopes. So let's cover what is an ion. An ion is essentially a charged particle, meaning that the number of electrons are not equal to the number of protons. So if the number of when they're not balanced, then they will have either a positive or a negative charge. So when you have more electrons, obviously, if you guys can remember, electrons always have a negative charge, and a proton has a positive charge. So when you have more electrons than protons, you have a negative charge, and you call them an anion. And when you have more positive charges, more protons than electrons, you have a positive charge. And those ions are called cations. Positively charged ions are cations, and negatively charged ions are anions. And ions are essentially when electrons are not equal to protons. That's a simple definition of ions. So, what an ion, that is like your textbook definition. But we have to understand really, where does it come from? Well, an ion actually, as you said earlier, it can gain or lose electrons from its valence shell. So, as you guys remember from our previous lessons, a valence shell is essentially the outermost orbital of an atom. Okay, so in this case, we have magnesium. So our valence shell is going to be the valence shell number 3, this one. And based on this, the atom will choose its most favorable way to gain an octet or gain a full shell. A full shell means that it has 8 valence shell electrons. And you can either do that by gaining electrons or losing valence shell electrons. In this case, we have 2 valence shell electrons. So you go along your valence shell and you see how many electrons are on there. In this case, magnesium has 2. So 2 valence shell electrons, it would choose. Is it more favorable for it to actually gain 6 more to have 8 valence shell electrons? Is that more favorable than actually losing 2 electrons and then having your valence shell as this one, number 2? And number 2 is actually already full, right? 8. 1, 2, 3, 4, 5, 6, 7, 8. It already has 8 valence shell electrons. So it will be more energetically favorable for magnesium to lose these 2 valence shell electrons, and then it will now lose this valence shell, and our new valence shell is going to be number 2, and number 2 already has 8. So instead of gaining 6 electrons, it is more energetically favorable for magnesium to lose 2, and then you have 8 on the new valence shell. So that is how ions form, and to determine ions, as we said earlier, magnesium wants to lose these 2. So we will have magnesium will have a charge of 2 plus because it lost 2, right? So now we have more protons than electrons here in this magnesium atom, because we literally lost 2 electrons, right? In the protons, we still have the same amount of protons, but we lost 2 electrons, so we have more protons than electrons, so we will have a positive charge. And we lost 2, so we have a positive 2 charge. That is how you determine the charge for ion. Before I get to isotopes, I want to talk about the periodic table. Each box in the periodic table will have one number here, which is the atomic number. And we'll also have another number here that is called the atomic mass. The atomic number is the number of protons or electrons. The number of protons and electrons are the same in a neutral atom. Atomic mass is the number of, atomic mass is the, atomic mass is the number of protons plus neutrons. Because both protons and neutrons carry a mass of 1. So the total atomic mass would be protons plus neutrons. And atomic number, again, would be protons or electrons. Like, both of these have to be the same number. Like, let's say the atomic mass of 7 means that number of electrons equals 7, and number of protons also equals 7. And number of neutrons would be neutrons subtracted by the atomic number, because protons plus neutrons equals mass. So if we're given mass here and we're given protons here, to find neutrons would be mass minus protons. Okay, so that is your little introduction to the periodic table. So now to get back, what is an isotope? An isotope is when the number of neutrons is not equal to the number of protons in an atom. So that's why they indicate by a mass, by a X element hyphen and then your mass of that isotope. That is your format. Okay, so this would be your mass. That will be the number of protons and electrons. Numbers protons and neutrons. Sorry. So that is the basics of an isotope. So we now complete a table. Okay, this is a worksheet to practice. So atomic number is given 32. Let's go back to our periodic table. 32 is going to be germanium. Germanium. Name. Write down germanium. Nuclear symbol. This is a new thing. Nuclear symbol. First step, you write your name of your atom, and then on the top left, you write your atomic mass, which is going to be 72, and then on the bottom left, you write your atomic number, which is going to be 32. So that is your nuclear symbol. Okay. Number of protons is the same as the atomic number, so it's 32. Neutrons is mass minus atomic number, which gives you 40. And electrons is the same as protons, which is 32. Okay, and next column we have atomic number is 13. Look at your periodic table. You scan for the number 13 on top here. So you scan for number 13. It's going to be aluminum. So write down aluminum. Okay, and here Al, your atomic mass, unknown. Let's look at this. Mass 27. Round to nearest number, please. Nearest what number? 27 on top and 13 on the bottom. Mass on top, always mass on top, and then number on the bottom. For the periodic table, it's opposite. Okay, periodic table, it's the opposite. You have mass on the bottom and your atomic number on the top for the periodic table. And for this nuclear symbol, it's vice versa. Protons is 13. Neutrons is whatever that is, and then electrons is the same as protons. Okay, last, I'm just gonna skip these because I think it's a bit too straightforward. I'm just gonna do it. Okay, I'll do 2 more. Okay, we have protons, neutrons here. So protons, we know that protons equals atomic number, so 19. Let's look at 19. Scan for number 19. 19 is going to be potassium. Potassium, mass of potassium is going to be protons plus neutrons, 39. Electrons, same as protons, 19. Potassium, your symbol there, mass on top. The bottom is going to be your number. Okay, and then mass is 51 and electrons is 23. And we know mass, and because electrons are close to protons is also 23. And your number is also 23. Neutrons is 51 minus 23, which gives you 28. Okay, this will be, you scan for number 23. Where's 23? 23 is vanadium. I don't know how to pronounce it. Vanadium. Okay, you write your atomic symbol there. I'm pretty sure it's V, right? Yep, it is V. And your mass is going to be 51 in it. Yeah, okay. Mass is 51 here, and your symbol would be, and then you have your number be 23. Okay, straightforward. Complete this table. All the atoms are neutral. Okay. This is also very similar to it. I'm just gonna do these first two. Aluminum. AL's aluminum. You guys should memorize all of the first 20 symbols already. That's gonna be bromine. Okay, protons is an atomic number below here. Neutrons, is actually number mass minus protons, which gives you 14. Electrons the same as protons, which is 13. Protons here, electrons, same thing here, and then we have 79 mass and 35 protons, which gives you minus these two, as I said earlier, which gives you 44. So that's done. Okay, now we're moving on. Okay, this is isotopes now. Okay, nuclear symbol, C here. You know that, again, I said earlier, mass on top, 14. And we have to find out the number of protons and neutrons and electrons. So carbon gives you the name already. Go find carbon on your periodic table. Carbon. Boom, found it. Carbon, atomic number of 6. As I said earlier, the atomic number of it never changes. Okay, so 6. Okay, protons 6, electrons same thing, 6. Neutrons will be 14 minus 6 gives you 8. See one more. Bromine of 81. Bromine 81 on top here because it's a mass. Then you go find bromine on your periodic table. Bromine. Let's go find it. Where the hell is it? Here, 35. Okay, that'll be your atomic number. 35. Okay, from here you can figure out these columns pretty easily. 35 here. Neutrons would be this minus that. The mass minus number, which is 46 neutrons. Okay, now we're moving on to ions. It's a bit more difficult, I think. Okay, yeah. Symbol Cu3+. This symbol basically means that, as I said earlier, 3 plus means that it has lost 3 electrons. Okay, so element, number of protons, and number of electrons. Okay, we will go search for, first step is we're going to search for aluminum on our periodic table. Aluminum 13 is our number of protons. Never ever changes. 13. Okay, electrons, you know that I lost 3 electrons, so we will have 16. Copper, let's go find copper. Where's copper? Cu. Okay, here. 29. 29. So you have your protons is 29. And we know that this is copper. 29. And we know that electrons, it lost 3. So 32. Your number of electrons. Okay. Sulfur. So a few more. Okay. Sulfur. Let's go find sulfur. Sulfur. I can't seem to find it. Okay. Where is S? Okay. So 16 as your atomic number. 16 atomic number. So 16 here, and we know that we have the electrons, 18 electrons. 18 electrons means that it has gained 2 electrons, so it will have a negative charge of 2, right? Because it has 2 electrons more than protons, so 2 more negative charges than positive, so you have 2 negative for your sulfur, right? P, potassium, 3 minus, so go search for potassium on here. Where's, oh no, potassium. It was P is phosphorus, right? Yep. Let's go find phosphorus. Where the hell is phosphorus? Here. 15. So you know number of protons is 15. Okay, phosphorus number 15 here. Number of electrons, we know that this is 3 minus, meaning that I gained 3 electrons. Okay, last one, magnesium. Magnesium, Mg, we do know number of electrons, so let's go find Mg. Mg, where is it? 12. So 12 is your number of protons. 12 is your number of protons. Number of electrons is 10. It lost 2 electrons, so it will have positive 2 charge. There. That is how to deal with these types of problems. Last one, just drawing your ions in atoms. Boron atom. Okay, I'm just gonna do one example here. So I'm gonna do like oxygen, okay? So it's oxygen. This is like more straightforward, no thinking type of question. Oxygen, we know that it has 8 protons. So let's draw 8 electrons as well, because the number of protons and electrons are always the same. So let's draw 8. 1, 2 here. 4, 5, 6, 7, 8. Okay. So we have 8 total electrons, but we have 6 VSE, 6 valence shell electrons. 6 electrons on your outermost shell, okay? Ignore this one here, because that's like a template that they use for this worksheet, so ignore that one. So now, for a normal oxygen atom, it will only have 6 valence shell electrons. So my question is that, would it rather to lose 6 valence shell electrons, or gain 2 to obtain a octet, to obtain 8 valence shell electrons? So would it rather gain 2? Okay. Would it rather gain 2, or would it rather lose 6 in order to gain a full shell? It can, because a full shell can either mean 2 electrons or 6. Like the first shell is always 2, right? And so it can either lose these 6, or it can gain 2 electrons to have a full shell. What is more energetically favorable is obviously to gain 2 more. So you're gonna draw 2 more here. So now you have 1, 2, 3, 4, 5, 6, 7, 8 total valence shell electrons. So obviously This is your oxygen ion. You draw square brackets around it, and you indicate the charge of 2 minus because it has gained 2 electrons. Okay. This. Do I really have to do this? It's like pretty straightforward on repeat. Let's do this. Okay. Atomic number 8. No, 8. Yeah, 8. Mass number. Check. Mass number is 16. 16 neutrons here, cation, anion. So we obviously know it's a negative charge, so it's gonna be anion. Okay, ion symbol, oxygen 2 minus. So atomic numbers always stay the same here. Mass number always is it's gonna be the same here as well because only the number of electrons change, not number of neutrons. And now number of neutrons here always is still going to be the same here because it's not an isotope. Only number of electrons changed up to 10. Okay, that'll be how you fill out this chart. This chart.